So if you are new to, hello, yeah. So today we will be discussing the concept of the controllability and the concept of the observability. So those of you who are new to the channel, you can kindly subscribe the channel and see the previous videos to understand uh, the concepts. Okay, now let's start with the controllability. So controllability is a part of the study state space analysis. So it says that a control system is said to be controllable. I'll write down a control system is said to be controllable basically when if the initial state if the initial state of the control system if the initial state of the control system are transferred, or I can say changed, to some other state, to some other desired state by a controlled input of infinite by a controlled input of infinite duration, input of, okay, of by a controlled input of infinite duration, okay, infinite duration of time. So how to test for this of time, whether a system is controllable or not? See, we can say that for a control system, the controllability of by using a particular test. So this can be done by following the Kalman's test. So if we have any control system, we can use the Kalman's test by writing it in a matrix form, that is a controllable matrix, Kalman's QC form. So we will have this matrix in this form: B A B A square B raised to the power A n minus 1 B. So this is how it is done. So once we generate this matrix, then find the determinant of this matrix. Find the determinant determinant of matrix, and if its value is not equal, if it is not equal to 0, then we can say the system equal to 0, then the system is the system is controllable. Okay, so this is basically the definition of a controllability, controllable. Similarly, a system is called observability. For this I will give you the definition: observability. So a system is said to be observable when if it is able to determine the initial states from the find. If it is able to determine initial states, I'll write down initial states. Okay, from where? Initial states of the control system by observing initial states of the control system. Let me write CS, control system, by observing the outputs in finite durations of time, infinite durations of time. For this also we have a particular matrix that is given by the Kalman to CQO, that is the observability of the system. For that we have CT, C transpose, A transpose. Okay, for first, sorry, first term would be just C transpose, then second term A transpose, C transpose. Okay, so on and so forth. It happens. Okay, A AT, then this is the square term would be there. So for the first term you had AT square CT. Similarly, you go on up to AT n minus 1 and be followed by CT. So this is basically the equation for the controllability and the observability. Let's verify from our example, okay, whether the system is controllable or observable. So we have a system here wherein x value of x is equal to x1 dot x2 dot, that is given as -1 -1 1 0, wherein it is x1 x2, okay, plus 1 0 u, and here y is equal to 0 1 x1 x1 x2. So here you see this is a. Now you can get the a value, that's the state matrix minus 1 1 1 0. You have the value for b as 1 0. You have the value for c as equal to 0 1. Now as for the controller, the system is supposed to be, and d is equal to 0. Now if the system is said to be controllable, so here you see the value of the matrix is for, it remains for n here is 2, because it's a square matrix, it's a 2 cross 2 matrix. So the matrix now, because it's a square matrix, for controllability we had the equation b, and only a b term will, because a n minus 1 is basically a, 2 minus 1 is nothing but a power 1, so it will just vanish up to here, b into ab. So the matrix b I already know is 1 and 0. And what about the AB? A into B would be equal to minus 1, 1, 1, 0, and here it is 1, 0. So in order to get this AB, so what I do is that whenever I have to multiply, this is my row, this is the column. Okay. The first term minus 1, so first term would be minus 1 here for the first. Then here row 1, so here it would be 1. Okay. So basically multiplication is row multiplied by column and the first value. So it put and addition. So here it is like minus 1 into 1 plus 1 into 0. So that is the reason I have minus 1. Down there, is for the second row. Okay, for the second row, it is, see, 1 into 1, right? 1 into 1 plus 0 into 0. So I have this term as 1. That's why, that's how I got. So now I can get this matrix QC. B, I already know 1, 0, minus 1, 1. Now I need to find the determinant. So this is 1 into 1, 1, and minus 0 into minus 1. So this matrix value comes 1. It is not equal to 0. So hence I can say the system is controllable. System is controllable. Okay. On a similar grounds, if I want to find whether the system is observable or not, let me do it here only, so not to waste your time. Okay, let's rub this. Okay, so we know that the system is controllable. Now for the observability part, you know the equations clearly, that is CP A transpose CT equation. That equation we will formulate, and we will see whether the system, whether the value of the determinant is 0 or not. If the value of the determinant is not 0, it is coming any other value, then the system is observable. Okay, so the value of B here was equal to, how much was the value of B was 1 and 0. Okay, now for the observability part, again for this, for n is equal to 2, so q naught would be equal to 8 and minus one term t would be there, no? So it would be ct and a transpose c transpose. So c transpose is, this will become a row matrix, it will become into column matrix. So c transpose will become equal to 0 into 1. Okay, this is the most important part. It can come for 20 marks. Okay, it's very easy to fetch these two. And a transpose here would be, what we have to do, this row we have to convert into column. So it is minus 1 1 here. This we will write in the column form here. Here also 1 0. This is row, so it will be written in column form 1 0. So our this transpose will become this. Now I have this value as 0 1. Okay, then this I 80 into C transpose. So what is the value of C transpose? C transpose value is 0 into 1. Again, for the multiplication purposes, this is the row into the column. So first minus 1 0. So the first term will become 1. By now you must have understood row into column. So 1 into 0 0. Okay, 0 into 0 0. So what is the value of A transpose C transpose? So I get 1 0, right? So this is 0 1 and this is 1 0. So what about this? What about the determinant of this? Can you tell me the determinant of this? The determinant of this value basically is equal to, okay, so if I can calculate, go for the calculation of the determinant. Okay, so if you avoid the determinant of this value, the determinant of the matrix Q naught is not is basically not equal to 0, you'll get the determinant value to be equal to -1. Okay, so it will be, so you please yourself try. This determinant would be equal to minus, the value would be equal to -1. How it will be equal to -1? Basically the first term is, see, 0 into 0 minus of this 1 into 1. So the determinant value is -1. So we can say that QA is observable since the determinant is not equal to 0. Hope you have understood this. This problem is very important. So we'll end the lecture here. Those who are new, kindly see the previous lectures, and those who have come here for the first time, you can kindly subscribe it. Yeah, I'll end this lecture here.